and aluminium oxide respectively. Aluminium reacts with air to give, and you know that in air you have your nitrogen and also your oxygen. So aluminium reacts with air, which comprises of nitrogen and oxygen as one of the species, to give aluminium nitride in this respect. So this is aluminium nitride. While in the case of these, you have aluminium oxide. Aluminium, 4 moles of aluminium combined with 3 moles of oxygen gas to give aluminium oxide. So it combines with nitrogen to give aluminium nitride, and it combines with oxygen to give aluminium oxide. 2, it reacts with non-metals, especially chlorine, to form aluminium chloride. Aluminium combines with chlorine to form aluminium chloride. Reaction with acid. It reacts with dilute hydrochloric acid slowly but rapidly with concentrated form to liberate hydrogen gas. We have hydrochloric acid, we have H2SO4, and we have HNO3. When this is in dilute, the reaction is slow. When it is in hot concentrated form, rapid. So it means that aluminium reacts with this to give aluminium chloride. Aluminium reacts with acid in different degrees. With hydrochloric acid in a dilute form, the reaction is slow, where 2 moles of aluminium react with 6 moles of hydrochloric acid to give aluminium chloride and hydrogen gas. In the concentrated form of it, the reaction is rapid, giving the same product, but the difference between the dilute form and the concentrated form is that in the dilute form, the reaction is slow, giving the same product, while in the concentrated form, the reaction is rapid, giving the same product. Its reaction with tetrasulfuric 6 acid, in the dilute form, there is no reaction. Aluminium does not react with H2SO4 in the dilute form, no reaction. In the concentrated form of H2SO4, this H2SO4 is become oxidized to sulfur 4 oxide. So that means in the dilute form, H2SO4 does not react with aluminium, while in the concentrated form, the H2SO4 is being oxidized to give sulfur 4 oxide. In the HNO3, that is hydrogen triazonitrate 5, both the dilute and the concentrated form, there is no reaction. Aluminium does not react with triazonitrate 5 acid, both in dilute and concentrated form. These are the representation of the reaction of aluminium with various acids. Aluminium does not react with triazonitrate 5 acid at any concentration, simply because there is formation of a protective layer of aluminium oxide. Uses of aluminium. It is used in making cooking utensils. 2, it is used in making overhead electric cables because it is light and has good electrical conductivity. 3, aluminium powder suspended in oil is used in paints. 4, it is used in making alloys such as duralumin, compounds of aluminium. It occurs naturally as bauxite. Bauxite with the chemical formula of Al2O3. Preparation. It is prepared by heating aluminium hydroxide. When aluminium hydroxide and water. So when aluminium hydroxide is heated, you have aluminium oxide and water as the byproduct. And this is a simple way in which aluminium oxide can be prepared. Properties: it is a white crystalline powder. It is insoluble in water. It reacts with dilute acids and strong alkalis to form salts, that is amphoteric. When we say amphoteric, amphoteric oxides are those oxides that exhibit both basic and acidic properties. Apart from aluminium oxide, other oxides that are amphoteric in nature are zinc 2 oxide, lead 2 oxide, tin 2 oxides, and aluminium oxide itself. Uses: it is used in surface linings, ceramics, and synthetic gemstones. It is also used as abrasives. What are abrasives? Those are sharp tools that are needed to sharpen objects. Also for absorption in chromatography, and it is used as a catalyst in catalytic cracking of hydrocarbons. Next is aluminium hydroxide. It is precipitated when sodium hydroxide is added to aqueous solution of aluminium salts. This is aluminium with sodium hydroxide. So in this situation, you have your aluminium 3+ combining with the hydroxide in sodium hydroxide to give 3 moles of, or 3 atoms of hydroxide combining with 3 positive charge of aluminium 2, and this gives you sodium ion 3 moles. So here this is precipitated out because it is insoluble. So this is the simple way by which aluminium hydroxide can be obtained. Properties: it is amphoteric. Uses of aluminium hydroxide: it is used in dyeing industries as mordant. What is mordant? Mordant is a substance that helps dye to stick to the cloth. So aluminium hydroxide is used in dyeing industries as mordant. Preparation of another compound of aluminium known as aluminium chloride. It is done by heating aluminium foils in dry chlorine or hydrogen chloride. Aluminium chloride, however, it is a covalent compound which reacts with water. Most metallic chlorides are electrovalent in nature, but in the case of aluminium chloride, rather than being electrovalent or ionic, it is covalent in nature, simply because here you have a share of a pair of electrons between the 2 participants, which are aluminium and chloride. Then you have aluminium tetraoxosulfate 6. How is it prepared? It is prepared by the action of concentrated tetraoxosulfate 6 acid on aluminium oxide. Properties: it is a white crystalline solid which is moderately soluble in water. It forms alum. Uses: potash alum is usually used as a mordant in dyeing and also in coagulants in water purification. In the case of mordant, it has been explained as a substance which help dye to stick to clothes, while coagulants is the process. A coagulant is simply a substance that has the tendency to clump particles of dirt together to form a compound which become insoluble and can be removed by the process known as filtration. Compounds of aluminium order: you have aluminium triisonitrate 5, That is another compound of aluminium, but the chemistry of aluminium trioxonitrate 5 is not vast. Preparation. It is prepared by action of aluminium oxide and dilute triazonitrate 5 acid. Aluminium oxide on dilute triazonitrate 5 acid. So here, aluminium oxide combined with triazonitrate 5 acid to give aluminium nitrate and water. Aluminium hydride. Preparation. It is prepared by reacting excess aluminium chloride with lithium hydride. Lithium hydride plus excess aluminium chloride. Aluminium hydride, lithium chloride. So it is balanced. Here, the oxidation number of aluminium is +1 in the case of hydride, where it is -1. The oxidation number of hydrogen is +1, except in hydride, where it is -1. So aluminium hydride will exist this way. So this is how aluminium hydride can be prepared. Tin. Tin is another element in the periodic table, but the chemistry of tin not vast. It does not occur naturally as the free element. The main source is the mineral cassiterite